Hello everyone. In this lesson, we will work with finding the equation of a line tangent to a curve at a given point. Finding derivative of a function is more like you are finding the slope of a line tangent to a curve. If a point is given to you, then you can find the equation of that line. So I summarize the step into this chart for everyone. So let's go over this before we work with example number 1. Okay. So the steps are to find the equation of a line tangent to a curve at a given point. You are going to find the derivative of the function with respect to x first, and then you substitute the value of x into that equation to find dy over dx, which is the slope of a line tangent to the curve at that given point. So using the point slope form of the equation to find the equation of the tangent line. So in this case, I put it in this form for everyone. Y minus y1 equal to m times x minus x1. And in general form of an equation is when you have to have one side equal to 0 and all your coefficients, your numbers and your term is moving to the other side, and the coefficient A, the coefficient B, and the number C are the integers. So general form, you are not allowed to have a fraction here. You also are not allowed to have a decimal number. So we will review all of this while we are working with finding the equation of a line tangent to certain curve and a point is given to us. Okay, so let's work with example number 1. So I have a circle, and the equation for the circle is y squared plus x squared plus y squared equal to 25. I'm sorry, excuse me. Then this equation representing a circle where the radius is actually equal to 5. Okay, so 25 is square root of 25 will give you 5. So the radius for this circle is equal to 5. And to find the equation of the tangent, the point is given to us is 3 and 4. So I just want to point to everyone where that point is. So that point should be right here. So from 3 I go up, and from 4 I go over. I meet at this point. So right there is my a given point 3, 4. And it fits the definition of the derivative also. So what is the tangent line? The tangent line is the line that touches the curve at only one point. Okay, so the slope of this line is the derivative of that of this function. So that means I have to differentiate this entire equation. And I have x squared, I have y squared. So it's best that I differentiate this function implicitly. Okay, to differentiate implicitly, I would like to remind everyone that I need to differentiate each term in terms of x. So you may want to start out by writing it like this. Derivative of x squared as a function of x or with respect to x plus derivative of y squared with respect to x, and also derivative of 25 with respect to x. So this is the first step that you want to write in terms of differentiating a function implicitly. So this circle here is x squared plus y squared equal to 25. And the point is right here as 3, 4 is given to me. And I must find the equation. Okay, so equation of this tangent line. And then I have to write it as sx plus by plus c equal to 0. Don't forget that a, b, c's are integer. Okay, so at this point what we are going to do is I will differentiate this with respect to x, every single term with respect to x. So I know that I have to review for everyone here. Okay, so what is derivative of x squared? So it will be 2x, and you time that with dx over dx. Okay, so excuse me, I think I better write this here, times dx over dx. And derivative of y squared is 2y, and you time this with dy over dx. Okay, and what is derivative of 25? Derivative of a constant is equal to 0. Okay, and you can just write 0 on this side of the equation. So now you take a look at dx over dx is just 1, so you can cancel that one out. And what you have left with is the equation will be 2x plus 2y times dy over dx is equal to 0. Differentiating implicitly means that you will have dy over dx as your unknown, and you are going to solve for that. So that means I'm going to move 2x over to the side of the equation. So I will have this written like this, and negative 2x. Bring this over, 0 subtract 2x. So now I'm solving for dy over dx, so I write dy over dx equal to negative 2x over 2y. So at this point, you see you can cancel that. So it just become negative x over y. So now the step that indicate up here for me is that I am going to substitute the values, given values in here to me into my differential equation to solve for my dy over dx. So in this point, given x equal to 3 and y equal to 4, okay, I can evaluate dy over dx, evaluate at the point 3, 4. So this is a notation here, okay, will be equal to negative 3 over 4. So this is the slope m that I'm talking about. So now you are finding the slope, and a point is given to you. You can substitute that into this equation. Okay, so use point slope form. Y minus y1 equal to m times x minus x1. This is the slope right here to find the equation of this tangent line. Okay, so I just want to see if I give myself more room. No, I didn't have any more room, so I better write it a bit smaller. Okay, so the slope, this is the slope of the tangent line, so I just put the mt. Okay, so now using the point slope form, that means I will use y minus y1 equal to m of x minus x1. So this is the equation that we need to remember for ourselves. Okay, so this is the point slope form of the equation. It has the y, it has the x, and then the slope here is actually the slope that you just found after you differentiate and then you substitute the values in, and x1, y1 are the value 3 and 4 that given to you. So I will have y minus 4, because y is given as 4, y1 is 4. Then slope is negative 3 over 4, and then x subtract 3. Okay, so 3, 4 here, I just want to make a note for everyone. This is my x1 and this is my y1. Okay, so in here you can identify this as x1 and you can identify this as y1. So the next step is to simplify this equation and arranging the value so that we can have the ax plus by plus c equal to 0. So what I strongly recommend everyone to do is, since I divided by 4 here, I will multiply 4 over to this side. Okay, but when I multiply it over, I will multiply that with the entire binomial y minus 4. So then I can get rid of the denominator right away. Alright, okay. So now you can multiply it in, or you can distribute the term. Okay, so when I distribute, I will have 4y subtract 16. This one equal to negative 3x plus 9. So now you see you have all the integers. The coefficients are integers, and you have just the number as integer. So you can go ahead and move everything to one side of the equation. Let the other side equal to 0, and then you will have the equation for this tangent line in general form. So when I move this one over, I have this equal to 0. So I should have 3x plus 4y, okay, minus 25 equal to 0. So this is my final equation, and in general form. As required. Alright? Okay. So what is A? A should be equal to 3, B equal to 4, and C is equal to negative 25, as indicated in here. Alright. Okay. So this form is always required. So we make sure that we simplify our equation, and we need to write it in general form. Okay, so let's move on to our next question. Okay, so in this example, I'm asking everyone to find the equation in general form. Okay, so again, in general form. So that make a note here is ax plus by plus c equal to 0. We talk about general form of a line tangent to the curve. As soon as you see the line tangent to the curve, you know that it is the slope. You have to find the slope so that you can write the equation in general form. So how do you get the slope? Is to differentiate the equation. All right. Okay, you have to differentiate the equation. Your dy over dx will be the slope. So I am having y equal to 2x minus 9. So I have as a square root, under the square root, this square root representing that I have a parabola open to the side. So I have this parabola, square root of 2x minus 9 is open to the side, is this parabola right here. Okay, so let's trace the step for this parabola. I have this one. Okay, so the square root means that I have a parabola opens to the side. And then I'm giving this line. So I'm given this line here. And I need to find the equation for this tangent line. Okay, so I think I try my best so that I show that the parabola is touching this line at only one point. So I better do that again. Okay, so if you don't mind me, I just quickly. Okay, so in the way that is representing, it only touches this curve at only one point. Okay, so then what we are going to do next is you are going to differentiate, right? So you differentiate this equation right away, and the slope is given to you instead of a point. So when the slope is given to you, so the slope here equal to 1, it means that it's equal to dy over dx. Okay, so if I differentiate this equation, what do I get? Okay, so let me pause a few seconds, and I just want to tell everyone in previous example, I am giving you a point to work with, right? X equal 3, y equal to 4. But in here, I don't give you a point to work with, but don't worry about this. We will be able to find the equation very easily. But the first thing you do is you have to differentiate, and we have to differentiate correctly. right? So let me write y equal to, so this one here is y equal to the square root of 2x minus 9. Okay, so for 2x minus 9, in order for me to differentiate, I need to write 2x minus 9, all of it to the exponent a half. Okay, so now you are raising a function to a power. You need to apply the chain rule. So I will take a half, multiply 1 in front of the bracket. So I will have a half 2x minus 9. Take 1 away from the exponent. I should have negative half left. And I should take derivative of what inside the bracket as well. So in this case, derivative of 2x minus 9, derivative should be 2. Okay, derivative of 2x is 2, derivative of negative 9 is 0. So we can cancel something out here. So I can cancel that out. And I am having this written as dy over dx will be equal to 2x minus 9, all of it, to the exponent negative a half. And don't forget, this is actually equal to 1, right? So equal to 1. So this is the slope. So this is in fact dy over dx here. Okay, so there it is. dy over dx equal to 1. So now you can use this equation. Okay, you are going to solve the equation for x, right? Okay, so if you write this equation down like this, so you have 1 equal to 1 divided by 2x minus 9 as a square root. Okay, so I will bring it down to the denominator as a positive exponent, and then I convert that into a square root. So now you see this equation here is easy for you to solve for x. So this is an equation with one unknown, so you can go ahead and solve for x. And instead of writing negative half, you put divided by square root of 2x minus 9. So make things a lot easier for you to solve for x. Okay, so to solve for x, I will multiply this over to this side. That equal to 1. And I have to square both sides in order to get rid of the square root. So I will put 2x minus 1 here, and I square this. I will have 1 square as well. So that means I am going to end up with 2x. This is 9. I'm sorry. 9. 2x minus 9 equal to 1. Right? Okay. So with 2x minus 9 equal to 1, it turned into just a linear equation, and then you can easily solve for the values for x. Okay, so 2x minus 9 equal to 1. Therefore, I will have 2x equal to 1 plus 9, which is equal to 10. So x is equal to 10 divided by 2, so x is equal to 5. Okay, so given after we found x equal to 5, okay, we can substitute x equal to 5 into the original equation to find y. Okay, so let me go up to our graph. Okay, so when x is equal to 5, which is this point here, so you want to project it up to find what the value for y. So hopefully when we find that, we should have 5 and 1. Okay, so we don't want to guess on the graph, but we want to see this is our original equation. Then what we will do, we substitute the values for x in here, and then we can find the value for y. And in this case, I hope it will be equal to 1 according to the diagram. Okay, so then I will have y equal to the square root of 2 times x, so 2 times 5 minus 9. So that means the square root of 10 minus 9, so square root of 1, so equal to 1. Okay, so let me write here so we can remember that our equation is the square root of 2x minus 9. Alright? Okay. So now I have the 2 points, the 2 point xy that I need, or the coordinate. Okay, so I have 5 and 1, right? And slope equal to 1 as given. So that means I can put it into this equation to find the equation in general form for this tangent line. So I will write it like this. I will write y minus 1 equal to 1, which is the slope, x minus 5, right? Okay, so y minus 1 equal to x minus 5. Now I'm moving everything over to one side so that I can have the equation in general form. So in this case, I will put 0 here. I will move this over to the side. Okay, so in the end I have 0 equal to x minus y minus 4. So this is the equation in general form for this. So I just want to remind everyone that this and this are just the same, okay? The same as I write x minus y minus 4 equal to 0. They are the same. Okay, so in this case, you have a equal to 1, b equal to minus 1, and c equal to minus 4. All right, okay. So let's write this equation into our line. Okay, so this one should be x minus y minus 4 equal to 0. It's the equation for this tangent line that we have to find. All right. Okay, so let's go up to our example number 2. I want to write the equation in here as well. So the equation for this line should be 3x plus 4y minus 25 equal to 0. So let's write it in here so we can complete our diagram. So this will be 3x plus 4y minus 25 equal to 0 is the equation for this tangent line at the point 3, 4. Okay, so basically in this application is you are going to find the tangent of a line tangent to a tangent line to a curve at a given point, and because that given point is given to us in terms of x and y, you can use that value to find the actual equation of this tangent line. And don't forget, it's emphasize the idea that dy over dx is the slope, okay, and dy over dx is the derivative. So finding the derivative of a function is leading you to find the slope of a line tangent to a curve at a given point. All right. I just want to remind everyone that this lesson, I make it together with the normal as well. Okay, so for the normal lines, I will do it in the next video. However, it's a good idea that I mention the line normal to a curve right away, and then I will repeat it in the next video. Alright, okay. So for a normal line, okay, what you have is a tangent line is the one that touches the curve at that only one point. So it touches the curve at only the point 3, 4 or the point 1, 5 that we found in this two example. So if the line cutting the curves at 2 points, then you don't have a tangent line. So you will have you cut that curve into then it's just a straight line. Okay. If you have a line that touches a curve at only one point, then it's called the tangent line. So with that tangent line, right at that point, if you draw a line perpendicular to the tangent, then that line is called the normal. Okay. So in this case, you see here, I have a line tangent to the curve this line tangent to this curve, and if I draw a line that perpendicular to that tangent at that given point, then it becomes a normal. So what I will do is I will work with the normal lines in our next video. So it's just a quick reminder for everyone. Alright, thank you.